Significance of fictitious force. Physical significance of fictitious force. Fictitious force. Physical significance of fictitious force. The acceleration a and a dash are related by the equation vector a equal to vector a dash plus 2 omega vector cross vector v dash plus omega vector cross vector r. Multiplying both sides by m, we have multiplying both sides by m, we have m a vector equal to m a dash vector plus 2 m omega vector cross vector v dash plus m omega vector cross vector r. According to Newton's second law of motion, the effective force on the particle of mass m in the uniformly rotating frame S dash is given by m a dash equal to f dash vector, and the true force in the inertial frame S is given by ma vector equal to f vector. Substituting the equation number 1, we get this is the equation number 1. This is the equation number 1. Substituting in equation 1, we get vector f equal to vector f dash plus 2 m omega vector cross v dash plus m omega vector cross vector r. So f dash vector equal to vector f minus 2 m omega vector cross v dash vector minus m omega vector cross r vector. So f dash vector equal to f vector plus f0 vector, where vector f equal to minus 2 m omega vector cross v dash vector minus m omega vector cross vector r is the fictitious force. Acting in the non-inertial frame. Acting in the non-inertial frame. Fictitious force equal to Coriolis force plus centrifugal force. Centrifugal force. Centrifugal force. The Coriolis and centrifugal force are a consequence of rotation of frame of reference. Coriolis force. Which force? Coriolis force. Coriolis force. Coriolis force. The Coriolis force is given by -2m omega vector cross vector v dash. V dash. It is defined as the fictitious force. It is defined as the fictitious force which acts on the fictitious force which acts on a particle which acts on a particle when it is in motion relative to a rotating frame of reference. Relative to a rotating frame of reference. Rotating frame of reference. It is proportional to the angular velocity omega of the rotating frame and to velocity vector v dash of the particle relative to it. It will obviously be zero if either v dash or omega is zero. If the particle is at rest relative to the rotating frame or if the reference frame is non-rotating one. The direction of Coriolis force is always perpendicular to omega and v. The direction of Coriolis force is always perpendicular to omega vector and v vector dash. It is that angular velocity of the rotating frame and the velocity of the particle relative to the rotating frame. The negative sign indicates that the negative sign indicates that Coriolis force is in the direction opposite to that given by opposite to that given by right hand screw rule. Right hand screw rule. Coriolis force can be written as Coriolis force, Coriolis force, Coriolis force equal to minus 2m omega v dash, omega v dash vector sin theta n, sin theta n, sin theta n, where vector v dash are the magnitude of omega v and theta is the angle between the direction omega and v dash, and n is a unit vector perpendicular to both omega and v dash. If theta equal to 0, if theta equal to 0, then Coriolis force equal to 0. This is so when the angular velocity vector of the rotating frame and the linear velocity of the particle relative to the rotating frame are parallel. If theta equal to pi by 2, then sin theta equal to 1, and Coriolis force equal to minus 2m omega v dash, minus 2m omega v dash, which is the maximum value when omega and v are perpendicular to each other. This is the maximum value. Maximum value if omega, vector omega perpendicular to vector v dash to each other. Coriolis force is maximum. Coriolis force is maximum, and this is the figure. You can also know about the figure. Angular velocity omega. This is the origin point O, central of rotation. Central of rotation, and centrifugal force. This is the centrifugal force m omega square Rn vector, and this is the 2m omega cross vector v dash Coriolis force, and this is the linear velocity vector v dash, and next is centrifugal force. What is centrifugal force? Next is centrifugal force. Centrifugal force. The centrifugal force is given by minus m omega cross omega cross r. It is defined as the fictitious force which acts on a particle. The fictitious force which acts on a particle, at rest relative to a rotating frame, of reference of reference. It is numerically equal to the centripetal force, but it is oppositely direction. It is numerically equal to the centripetal force. Equal to the centripetal force, but it is oppositely direction. But is oppositely directed. But it is oppositely directed. Is that outward away from the axis of the motion. Outward away from the axis of rotation. Its value is m omega square rn vector, where rn is the distance of the particle from the center of the rotation of the components of vector r perpendicular to the axis of the rotation. Where rn is the distance of the particle from the center of rotation, are the components of vector r perpendicular to the axis of rotation. Perpendicular to the axis of rotation. It is clear from the above discussion that Coriolis and centrifugal force are consequence of rotation of frame of reference, whereas centrifugal force acts on a particle at rest relative to a rotating frame of reference. Coriolis force acts on a particle having a velocity with respect to the rotating frame of reference. In other words, Coriolis force owes its existence to the motion of a particle with respect to a rotating frame of reference. Okay, thank you.